Today's video will follow the experimental setup section for the 820MO organ bath system. We will be mounting mouse aortic rings on the 820 chambers. We will cover dissection, cleaning, and mounting of the aortic rings on the chambers, and then follow a standardization or normalization, a wake-up protocol, and a few agonist responses. You can pin the ends of the aorta in your dissection bath. Clean along each side to remove the excess tissue. Try to limit the handling of the ring in order to get the best results. And then cut the aorta in half. You can then measure and cut 2 mm segments from each half of the cut aorta. Transfer the 2 mm segment of the aorta to the 820MO bath. Then, holding the ring by the end, you can slide it onto the 2 pins sticking out into the bath. Mount the ring closer to the base of the pins than towards the tips. You may need to separate the pins slightly so the aorta does not slide off when transferring back to the interface. After you've mounted your tissue, you can bring the chambers back to the interface, plug them in, and make sure you have your bubbling going. You can then start recording on the software and turn on the heat on the interface. After 20 minutes have passed, we can start the normalization process. Click on the DMT tab and go to Normalization Settings. In this case, we'll be using an eyepiece calibration of 1, a target pressure of 13.3 kilopascals, and an IC1 to IC100 value of 1. You can then go back to the same tab and open channel 1. Our tissue endpoints are 0 and 2, and our wire diameter will be our pin diameter, which is 200 microns. We will then take our first reading from the micrometer on channel 1, which is 8900. Then we can also simultaneously work on channel 2. In this case, our tissue endpoints are 0 and 2 as well, because each segment was cut to 2 millimeters. Again, our wire diameter is our pin diameter, which is 200. We can then take a reading from channel 2. Our starting point for channel 2 is 9,000 even. For our second point on channel 1, we will add a bit of stretch and then take another reading. Our second point will be 9,350. We can then go to channel 2 and again stretch and take another reading. This is 9,460. After we have entered 3 points, you can then see the line of best fit according to the module. This is trying to find the right normalization target. You can see on channel 1, we still have a ways to go until we cross the target pressure line, which is our goal for the normalization. This means that you can take a larger step for your next point. The program needs a minimum of 4 points to accurately get a good target for the normalization. However, you will usually do far more than 4 steps. Channel 2 is showing the same response. As you approach the target pressure line, you should take smaller steps to avoid overstretching your tissue. Since each step takes a minute, you should try to add a decent amount of stretch between each point. Otherwise, this step will take a long time. You can see that channel 1 has now crossed the target pressure line. You now have a micrometer reading that is no longer an extrapolated result. You should move channel 1's micrometer to this calculated position. This is the calculated best point for normalization. You can see that channel 2 has also crossed the target pressure line. It's reading 10,237. So you can set channel 2's micrometer to that approximate value. This is the actual trace of the forces generated during normalization. And at the end, you drop it down to its optimal preload tension, as determined by the DMT normalization module. You should then wash out and wait 20 minutes before you start the wake-up protocol. After 20 minutes has passed, we can do our first exposure to KPSS. Mouse aortas are a tad more difficult to wake up than smaller resistance vessels like the mesentery. Therefore, you may need to do longer exposures to KPSS, as well as an additional exposure or two. We will start with our first KPS exposure on both channels. We will add a comment, KPSS, and then remove the buffer and add the high potassium buffer. After 5 minutes has passed, you should then do a washout on both channels. You should do 3 total washes over 5 minutes during the washout period. After your washout period, you can then do a second exposure to KPSS. Our responses to KPSS were the same for 3 exposures, so we can then proceed to the agonist testing. We will first constrict the aortas using PE for a concentration of 10 to the minus 5. After 5 minutes have passed and the response has plateaued, we can then give acetylcholine to help relax the aorta. We will use a concentration of 10 to the minus 5 ACH. You should make sure to perform your own concentration curves with your tissues and agonists, as there could be variations, and doing it yourself will help standardize your own experiments. After your response to ACH, you should then wash out both drugs over 30 minutes, and you can then proceed with the experiment. For more information on the 820MO system, please refer to the DMT website or additional resource videos.